Hi, I'm Seth Axon from the University of Tübingen, and I'm pleased to share with you our work on spatiotemporal modeling of European paleoclimate using doubly sparse Gaussian processes. Researchers in applied fields like paleontology need predictions of past climate at specific points in space and time with uncertainties. The information to inform such predictions comes in two forms. First, simulations from physical climate models are spatially gridded and sometimes available at multiple time points. Second are climate reconstructions from so-called proxy data, which are located at specific points in space and time. However, no consensus model combining these two sources of information is available. Our goal in this project is to construct such a model for global landmass that can be queried at any spatiotemporal point. I'll discuss here our first implementation of our model for the European continent. Our data are publicly available simulations from 10 paleoclimate models ranging from 21 to 6,000 years ago, and reconstructions from fossilized pollen data, for a total of over 600,000 data points. First, we construct a spatiotemporal Gaussian process prior for mean annual temperature. We also defined a Gaussian likelihood. For more details, please see our poster or the workshop paper. With these components, we could construct an exact spatiotemporal GP posterior. However, 600,000 data points is too many to perform inference. Instead, to make inference tractable, we trained a doubly sparse, variational Markovian GP that approximates this posterior. This approach combines inducing point methods with the state space representation of GPs. Inference then scales linearly with the number of temporal inducing points and cubically with the number of spatial inducing points. We validated this approach on a single multi-time slice simulation with leave one time slice out cross-validation. The mean validation error was 0.05 degrees Celsius, while the mean absolute error was 0.7 degrees. We then trained the GP using the full data set. Here we visually compare a single multi-time slice simulation with the mean of the approximate posterior. The mean is visually similar, and we can see it both spatially and temporally interpolates between the data, as exemplified by the time slice at 20.5 thousand years ago, where we have no simulation. The GP also predicted the non-gridded pollen data well. 99% of all data, and specifically 96% of pollen data, fell within 3 standard deviations of the mean of the posterior predictive distribution. In summary, we successfully built a consensus model of paleoclimate using simulations and pollen data, where we use a doubly sparse variational GP to make inference tractable. For more information about the project and links to the poster and abstract, please scan this QR code. And if you have questions or suggestions regarding this project, we encourage you to contact us. Thanks for your time.